Welcome. I'm uploading this class after around 3 days. There's a reason, because this is going to be a little long class. That's why, because of busy schedule, I'm going to record in parts. So once it is completed, I'm going to upload. See, all standard cases of location, see, I'll put here first of all standard cases of location of centroid. You can see one thing here. I underlined red color, then also green color. I will tell the reason for it, because see, even color also sometimes becomes important to understand. So all standard cases of location of centroid for lamina in the form of square, rectangle, triangle. Of course, triangle, multiple cases are there, circle, semicircle, and quadrant of a circle. I told lamina means plane area. See, plane area, you get centroid. Whereas only actually structural engineering, this plane area lamina means what? It is a cross section. Whereas when you consider the weight, it becomes center of gravity. I am telling this because, small reason. Recently, I saw a comment. Somebody is teaching me difference between center of gravity and centroid. He even he went to the extent of telling, you don't know how to explain the concept. Okay. Right now, I won't talk about anything about it. I got my own work here. I am busy in teaching and seeing that knowledge is spread. A little later, when I am free, I will give a reply to it. Maybe in the class only. But I will not talk harshly. People sometimes, they make a comment without knowing anything. He is telling something, it is this way. What I told, same thing he is telling. See, suppose I tell x plus y equal to z. In a comment he is telling, see, it should be x plus y equal to z. Yes, that is what I am telling. And then he does not know even how to explain difference between centroid and center of gravity. Some example, there is something where he tries to teach me also. People who know me, all the people who know me, I know they will take it as a joke, that's all. Immature joke they will take. Okay, right now I don't want to talk, because why? Let me come to the subject first. I just mentioned because, see, I am not going to delete it also. Let it be there. Let people know that how people mind works. When somebody is teaching properly and everything is giving, I don't know the reason for it. Okay, leave it now. Okay, that's all. All standard cases of location of centroid for lamina in the form of square, rectangle, triangle, circle, semicircle, and quadrant of a circle. With complete explanation, including numerical examples. In just one class. Class very, very important for entire chapter of centroid. Centroid is here in the beginning only. Just now we finished derivation. Lot of questions are there for entire chapter of centroid and moment of inertia, which is coming up, of course, and also for structural engineering, because in structural engineering, moment of inertia is the most powerful term. I will tell you reason, we will be knowing later. Now, therefore, I will advise everybody to go through each and everything I explain here. Do not skip anything. Thinking that even for square, I will tell the area. If the side is S, area is S into S equal to S square. Someone will tell. We know it. You know it, correct. But I am going to tell it. Because in the systematic order, everything should come. See, if you already know it, if I tell, you are not losing anything. You are gaining only. So many times what happens is people think they know. But how much they know, I know it. How much they know, I know it. Okay, then. Now, one important, see, just an example. See, by chance, you make a note here. Suppose a lamina is given randomly like this. you have to locate centroid and also find moment of inertia about centroidal axis. Imagine, so centroidal axis will pass through centroid of the cross section. See this, right here, this sketch. Maybe for example, centroid, I am expecting, see, something like this. This is a lamina, see. This is a lamina given. Actually, something imaginary, maybe somewhere, okay. Roughly, I decided. This is the centroid G for the entire lamina. Now, later, if you draw an axis here, this way, it will be called, usually I call X, capital XX, see. And if, see, it may not be here, it may be slightly this side also, need not be, I don't know. See, and an axis here, it may come, can come anywhere, okay. Maybe YY I will call, some name. This centroid you have to locate, and later you have to find maybe moment of inertia about XX and YY. Then, there is no standard expression for centroid for this lamina, this entire lamina, and also very irregular shape. What we will do is, see, most probably, see, what we will do is, see here. I will divide into parts, see here. Imagine this and this are same level. This way, then this way, and then here. This triangle becomes a triangle in general. For locating centroid, there is expression for centroid both this way and this way, but moment of inertia problem. So I will advise, in the centroid and moment of inertia, I will tell everybody, you divide like this, good for health. Okay. Then I may call this as figure number 1, maybe this is area number 2, see, area number 3, area number 4, something like that, area number 5. I will take a reference axis this way, then I will find x bar, distance of centroid, capital G, this G. I will take x bar, and I will take one more reference axis, and I will get y bar. When you get x bar, y bar, see, most probably, see, what I will do is, I will take a reference axis here, most probably. I will get this x bar. I will take reference axis here. I will get this y bar. Now, when you get x bar and y bar, you are locating capital G, that is centroid for entire lamina. That's what you require, centroid for entire lamina. But to get it, you are divided into parts. When you divide into parts, if you remember, x bar equal to 5 parts are there, a1, x1, a2, x2, etc. up to a5, x5, divide by area, y bar equal to a1, y1, a2, y2, etc. up to a5, y5, divide by area. So, we are going to divide. Now, when you divide here, there, a1, x1, a2, x2, what is that x1, x2 or y1, y2? They are distances of centroids of component, not this centroid. Once you divide into parts, see, there is a unique centroid for semicircle. Let it be a semicircle. There is a centroid for rectangle. See, for example, see here. Centroid for semicircle. I may call it G1. See, small g1. Centroid for rectangle, say G2. Centroid for this quadrant, I may tell G3. These two I can take a single stretch, but better I will take separately. Centroid here, say G4. One more centroid here, say G5. This G1, ink problem. Okay, 1 minute. See, this all you have to go through the class, read once again and understand. Then no, it will be clear. See, G1. Okay, G1. Small g, remember. Now, therefore, see now, once you get this one, this, see, capital G is centroid for entire lamina. Up to now, I was using capital G because up to now, if a rectangle given, only rectangle is there. When only rectangle is there, its own centroid itself is centroid for a given lamina. But now, when you divide into parts, centroid of components will be spread. But centroid G, this is G is centroid for entire lamina. So what I will do is, now onwards, the purpose of giving standard expression is to use them whenever you have to locate centroid, and later you may have to find moment of inertia about x, y, y. Then Some theorem is there, parallax theorem. See, if you want I about xx, first it is I about its own centroidal axis plus area into, see, suppose it is here, into this distance square, parallax theorem. That way, when you find moment of inertia, you have to apply parallax theorem. Then you require moment of inertia about centroidal axis of the component. See, entire lamina, these are centroidal axis. But for the component, its own centroidal axis, somewhere, you see, here, it will pass here. Therefore, location of component centroid is very, very important. For that, we have standard cases. That all I will, which everything we derived so far. Remember, none of that when I am giving as it is, you take that way. Okay. Why? So don't ask why. No. I derived it. Sometime when I teach for engineering students, if it is too much complicated, I will tell you take that way. I'll give an example for you. There's a method for Carney's method. For sway analysis, when different height of columns are there and when supports, fixed hinge both are there and lateral loads are in between, in a column, in between loads are there, it is highly complicated. The derivation, if I explain here, may take more than 5-6 hours, non-stop, and people can't make out anything. In such cases, I will tell them, I will give you final procedure. You believe me. Will you believe me? They will tell us, yes sir, we will believe. Yes, okay. Because when finally I solve, the result will come exactly same as what we got earlier by moment distribution method, slope reflection method, or column energy method, or strain energy method, or constant deformation method, any method. Answer. One method gives 18.899, 18.76. Every method will give you 18.76 only. Maybe 7, 5, 7, 7, 0.01, 0.02 difference may be there. That is because of approximation. Therefore, in such cases, I will tell them, proof is too much beyond your capacity. Still, if you want, I will do it. They will tell, no, sir. If you tell it is too beyond our capacity, then it is better not waste time because we cannot afford to waste time in the academic classes. Here, it is not academic class. It is a complete understanding. So, I derive each and everything. So that nobody should tell tomorrow something he told without proof. But when you go to RCC and steel, there are so many empirical formulas are there. That I can't derive. Why? Derivation is not given. Experimentally, they decided thumb rule or some empirical formula. You have to go. I will tell them, go to IS code and ask them. They will tell why you want it. Just like that. We go. They will tell go. We won't tell. You take the formula that way. Okay. Now, therefore, location of centroid. Now, up to now, I used red color for centroid. Why? Because rectangle, centroid, capital G. There is no component here. But now, if I use rectangle here, it is the centroid of the rectangle is not the centroid for the whole lamina. Therefore, now onwards, what I will do is for component centroid, see, for component centroid, I use small g. So now onwards, centroid, G means centroid, G. So anyway, you can make out G means, capital G means centroid for the entire lamina, small g means centroid for the component. That's why I am going to use green color even in future. Every time when in the chapter, centroid moment of inertia, when we are dividing into parts, they will be always green color. So that green color means one component considered, sufficient. Therefore, everything you go through, I am going to explain square, rectangle, triangle, circle, semicircle, quadrant, everything I am explaining. See, I will tell you what all you require. One you require is area. Square, rectangle, triangle, area, everybody knows it. Okay. Then, where is that centroid, small g? Now onward, small g, centroid. The location of the centroid, standard expressions. Some places, standard expression is not available to locate centroid in one direction. Then you have to split into parts and do it. That I will explain at that time. I told earlier also. Suppose trapezium. See, one thing forgotten here. Square, circle, triangle, see, extra. Also trapezium. I forgot, right? See, also trapezium. Trapezium limited. I will tell you what is standard, I will explain. Trapezium. Okay. Even trapezium also will come. That's why, and everywhere I will give numerical example. So this is a lengthy class. I may take some 3-4 days, or because I got a lot of commitments. Every day I have to take 3-4 hours outside class, and other commitments are there. So, and night time I have to record because of sound problem. So there is a limit. Sometimes it rains here. If it rains, sound will come. So I will record everything in an order, and when everything is over, single class I will upload. Maybe surely more than 1.5 hour or 2 hour. I don't know exactly how much. So now make all this note, and now I will start. One more thing I will do to save the time. I will not write each and everything here in front of you, because I am going to write something which is already proved, not something new. But everything I told in one class. Therefore, every time what I will do is, as I finish one round, I will pause the recording, come here, write neat sketches here, write whatever I want to explain, I will write, then I will explain. So now what you have to do is, all these notes you write somewhere outside, in your main notes. But the standard case what I am giving, write separately. Maybe 1 page for square, 1 page not required, 1 small sheet paper for square, a small for rectangle, a big drawing sheet for a triangle. Why? Huge triangle. Medium sized drawing sheet for trapezium. Circle, semicircle, quadrant, all one page. So you arrange so that later in the chapter of centroid moment of inertia or structural engineering, anywhere now onwards, I will always tell, go back to the class of engineering mechanics where I told all standard cases of location of centroid. Little later, when you finish centroid, we are going to moment of inertia. At that time also standard case will come. There, centroid also will come. Centroid I will not explain. At that time I will tell you, centroid already explained. Now I will explain only moment of inertia for centroidal axis. Maybe for rectangle or triangle, etc. I will tell at that time, see the expression is like this. But before that, we will prove it. Everything will be proved in the class. Summary I am giving. At that time, centroid will once again will come. But at that time, there will be no explanation. I will tell you, centroid already closed. Already explained earlier. So go back and see. Today you study moment of inertia, I will tell. Okay. Ready for everything now? I will start one by one in correct order. Maybe square and rectangle, single stretch I can do it. In single one sitting, I can do it. Anything else? Sorry, there is one more thing I have to tell. See, suddenly remember. Yes, now only I will tell. Now see, something suddenly forgotten. Okay, I will tell. Very important. See, I will remove this one now. It's all I am removing. Now, you should make a note of 2 important aspects. Okay, rough stick. But this is also equally important. See, sometimes you make a note here. Sometimes doubt comes, especially for a triangle. So many people, they get doubt. 2/3, 1/3 doubt. You should not get it. Natural feeling. Or make a note here. Centroid, see, centroid will be always that side where area is more. More area means if we consider the thickness of the lamina and calculate weight, center of gravity, the person who commented should come and see today. See, even for deriving centroid, we used center of gravity principle first. We considered thickness and considered weight. Then we came to centroid. Okay, leave it. I don't want to be harsh. Telling me what is the difference between centroid and center of gravity. Okay. Now, so therefore, where area is more, that side. For example, see here. See, imagine 1 minute. See here. I'll take a sketch here. Random sketch here. See, random sketch. This way sketch is there. Further, this. Okay. One side big. Okay. See, again, problem, 1 minute. But important, don't ignore. Later, if you get doubt, you are responsible. In case later doubt comes, means you are responsible. See. Okay. Some random. Centroid. I want vertically very centroid. See, come to midpoint. Oh, you will tell that side lesser area, this side more area. Surely centroid will be this side. See, okay, red color. Right now red color. Okay, centroid will be here. Okay, green, green. Okay, green. Why now component G. See, centroid is this side near, or maybe Indian map, not Indian map. Where is centroid? Vertically. Someone will tell, sir, that side more area. Ah, yes, therefore, now centroid will be near to bottom edge and far away from top edge. Near to bottom edge, far away from top edge. So, distance from bottom edge will be lesser. Nearer means lesser. When you are nearing a place, distance becomes lesser. Distance will be lesser, nearer to bottom edge. It is higher distance from top edge. Here, centroid will be somewhere here. Oh, this time, more area this side. It is nearer to top edge. This distance will be, this is nearer, lesser distance. This will be higher distance. Okay. That is for vertical distribution. See, both you take separately. When you do vertical, don't bother horizontal. Or horizontal. See, last point. Okay. Horizontal. See. Oh, color change. Okay, no problem. Color change. Where is centroid? Someone will tell, sir, that side is lesser area. See, sir, huge area this side, this way. Therefore, horizontally, centroid will be this side. See, it will be somewhere here. It is near to this edge. This is nearer by, this is far off. Or now centroid will be, somebody will tell this side. See, that side. Why? More area that side. Now, here, nearer to left vertical edge, far away from right vertical edge. Here, nearer to right vertical axis and far off from this axis. Make a note. Why you require is for triangle. So many places I have seen people suddenly getting doubt about 1/3, 2/3. One small mistake, very small mistake, that will completely spoil everything. I'll give a small example today. I'm actually in a very happy mood today because information for you. Indian Grandmaster Gukesh became today world champion. He defeated one more person from China, I think. China only, what I think, I know it. It was a drawn game which is going to be a draw. I am so sure, I know very well chess. It is, everybody told it is a draw. Next tiebreaker will come. One rook movement, he placed in the wrong place. It was just rook, bishop and pawn ending. He placed one small mistake. He placed in the wrong position. One small blunder, gone. Suddenly people started shouting, yes, match gone. He lost the match and Gukesh became champion. Oh, that's why I'm happy because I'm an Indian. But I equally feel sorry for other person. He is a very good fighter. Okay, one has to win, one has to lose. After Vishwanathan Anandan long back, at least India got one more champion now in world chess. Okay. Now, second concept, actually out of subject, I told because why? Because I just enjoyed everything. See, this introduction class I am recording today. Coming up some classes, already I recorded earlier. Introduction classes, I recording today because I was not in the mood earlier days to talk this way. So some of them already I finished. But this, when I edit that one, I will put this one first. You don't bother. So someone will tell, already you told 3-4 days, yes, some portion already ready there. The standard cases, majority are ready with me now. I prepared that one. But introduction part, I decided, lastly I will prepare. But when I edit, put it in the first. You know, Second powerful concept is, see, if there is an axis of symmetry, very, very important, symmetry, centroid will lie in that axis. If there is an axis of symmetry, centroid will lie in that axis. Therefore, in such cases, if the axis of symmetry is vertical, centroid lies there. So, horizontal distance not required. See, if it's vertical symmetry axis means centroid lies here. So, this way distance not required, only this way required. Or, if this is axis of symmetry, horizontal, then from vertically distance is fixed. Horizontally you have to locate, or you can remember that way. If there is an axis of symmetry, centroid lies in that axis. In such cases, you don't have to worry about both x bar, y bar. Only one of them is required. Other automatically comes because exactly center or exactly lies in axis of symmetry. It will come little later. Okay, now. And also wrote, if there are two axes of symmetry, then you don't have to worry. Then you don't have to bother about location of centroid, because then centroid will lie at the intersection of those two axes of symmetry. So if there are two axes of symmetry, then yes, see, you know the point now. See, if only one symmetry, it is somewhere in this line. If this is axis of symmetry, centroid may be somewhere here. If this is axis of symmetry, somewhere here. If there are two axes of symmetry, centroid is here at the intersection. So if there is one axis of symmetry, you need expression for locating only one of the distance, either horizontal or vertical. But if there are two axes of symmetry, you don't have to write anything, simply at the intersection of the two axes. Over. This I forgot to tell. Now I will go for next part. That is, I will start all standard cases in a systematic way with the numerical example and thorough explanation, so that permanently for lifetime you have no difficulty for locating centroid for a component. Okay, get ready. Now onwards, you should write all the statement I told earlier, you write. Now onwards, whatever I write, everything and explanation, separately write. One for square, one for rectangle. See, almost one page. Later, for a triangle, you may require 3 drawing sheets to understand. Trapezium, 1 drawing sheet. And circle, small part. Semicircle quadrant, maybe half drawing sheet. That you see later, so that any time you want, refer back and get it. Okay. Square, something, class. This is for the people who comment. Actually, square means we are not discussing geometric shape. In general, square means what? You know, I won't explain what is square. See, all angles are 40 degrees, sides are equal. So all angles are 90 degrees, sides are equal. Okay. All 4 sides are equal and both diagonals are also equal. Then automatically it becomes 90 degrees everywhere. I told, to save the time, if you want to write lamina in the form of a square. See, now onwards, when I put square here, to save the time, every class I can't write. You write every time now. If I write square means, someone should not comment. He is not telling what is lamina. See, comments coming. Okay. Lamina in the form of a square. Suppose I put rectangle, class, you write lamina in the form of rectangle, or, right, not lamina, area, plain area which is square in shape, plain area which is rectangle in shape. Later when I put triangle, right, lamina in the form of a triangle or triangular lamina, or lamina where the area is triangular, or furthermore better, I told all these are cross-section of members in structure engineering. A cross-section of a member, square in shape, rectangle in shape, later triangular in shape, trapezoidal in shape, circular in shape, or square cross-section, rectangular cross-section, triangular cross-section, circular cross-section, that way right. So don't tell that he just wrote rectangle, oh, it is not rectangle, it is a lamina. That only I told. There is a limit for writing everything. And one more thing. See, first, let S be the side. I take S for some reason, side S. See, S and S are equal. This is the sketch given. Come here. Neat, see, down after dotted line, neat answer. Mark yes, mark yes. Centroid is here. See, axis of symmetry, axis of now onwards, remember, centroid I am marking because these are all the components. I am using green color. But if square is the only section, or only what lamina, if only square is there, then the small g will become capital G. But if the square is a part of a lamina, other shapes are there, then it becomes small g. I told earlier, now red G I am not writing, capital G I am not writing red color, I am writing centroid, small g. Again, someone will comment, he wrote G without telling what is G. I told right now onwards for entire this today's class, small g means centroid of that lamina or whatever shape considered, that area considered, shape considered, or cross section considered. So don't waste time now, right here. Now onwards, somewhere you write. Every class I won't tell. G, every class means everywhere. G, like that. Okay. Start. Anybody in the road will tell S by 2, S by 2, S by 2, S by 2, area equal to S into S or S square. Somebody on the road will understand. Numerical example, square of side 250 mm. Okay, 250 millimeters. 250. Remember, all dimensions are in millimeter. This way. 250 by 2, 250 by 2, 250 by 2, 250 by 2, area 250 into 250. Now, one note you are right, powerful note. I will not tell, see sometimes people will tell, comment it, they will comment. He wrote some number without telling unit, does not know difference between meter, millimeter. I know the difference. Now onwards, make a note. Everywhere, when I give numerical example in today's class, dimensions are in millimeter. I won't write, see this I wrote here, all dimensions in mm. Next time not writing. I will just put here, I will put number. So when I enter a number dimension, now onwards for today's class, everywhere, remember, it is in millimeter. Therefore, everything, every time I am not writing millimeter in the bracket, all dimensions in millimeter. Why should I waste time? Is it that class? No. Therefore, now onwards, every numerical example given in today's class, dimensions are in millimeter. Okay, I will tell if somebody comments, can't you hear properly what I told earlier? No, I skipped that one. I came suddenly there. Then go back there. Okay. See, I told go back there. If you don't skip anything in my class. Okay. Sometimes people will tell, he's an arrogant person. I am not arrogant. I talk authoritatively. I want people to listen properly to me and understand. Everything is for your benefit I am doing, not for my benefit. Okay. Rectangle, class, I already told. Lamina, etc. you write. Okay. Let x naught, y naught be the sides, two sides. Some will comment. No, rectangle you call BD. You call BD. Why I am not calling BD? Because in structural engineering or later moment of inertia, it is BD cube by 12. B is called width. D is called depth. Suppose you turn it, then D will become breadth, B will become breadth, depth. So therefore what we do is, we will worry about that later. Right now, let x0 and y0 be the two sides. Let x0 be horizontal side, let y0 be vertical side. Later, when you do I about this axis, x0 become width, y0 become depth. It is x0 into y0 cube by 12. Later, if you do I about this axis, then y0 becomes width and x0 become depth. I will tell in the structure engineering class, depth is not vertical. People will tell, depth, he is telling width as depth. I will tell, have structural knowledge based on bending. There is no width and depth in structural engineering, are called structural width and depth, depends on bending. See, suppose I bend the scale this way for the cross section, this will become width, this will become depth. But if I bend it, this is bending. If I bend it this way, then this will become width and this will become depth. That I will tell you in the strength of materials class. So right now, that's why we won't get confused for B and D. What you will write? X0 be horizontal side, Y0 vertical. Okay, see, start. Neat sketch now, below, on dotted line. X0, Y0. Axis of symmetry, X0 means X0 by 2, X0 by 2. Y0 means Y0 by 2, Y0 by 2. Area, X0 into Y0. Okay, over. Numerical example. Here I wrote all dimensions in millimeter. Next time not writing. 120, 350, centroid here. See, 350 by 2, 350 by 2, and 120 by 2, 120 by 2. Somebody on the road will tell area 120 into 350. Answer not required. Okay. Square over rectangle over. Now, the most powerful, that is triangle. I don't want to pause now. For some reason, I will go to triangle now. I will give introduction now, then go there. I will have some explanation for you. You write everything. What all I tell you, write it. First, come to triangle. Before I write neatly, first some brief explanation. Triangle. Okay. Again, I told you, for those who want to put comment, triangle. Triangle, not triangle. A triangular lamina or a cross section of a structural member which is triangular in shape, or area, plane area triangular in shape. Here, center of gravity will not come, centroid will come. That much common sense I know. I am not that much weak. Okay, now triangle. Right here. Now triangle has got three parts. Three parts are case 1, case 2, case 3. Case 1, case 2, case 3. Why so big? The most important. Case 1, triangle in general, or triangular lamina for them. Triangle in general. In general. Case 2, isosceles triangle. Triangle. Case 3 is the most important. Right angle triangle. This is the most critical. This is the three cases for triangle. Therefore, what I am doing now is, first I am starting. 1 minute. Okay, 1 minute. I write and then start. So, three cases are there. Now, thorough explanation for three cases. Start now. Triangle. Big drawing sheet you require. I am going for case 1. Triangle in general. See, let B be the base. Never by heart B is horizontal vertical. B be the base and H be the height. Then let perpendicular from vertex, see, perpendicular from vertex, divide the base into two parts, B1 and B2. One side B1, one side B2. Total is B. See here. It divides the base into two parts, B1, B2. Now, very, very important. If the base is horizontal, height is vertical. or if the base is vertical, height is horizontal. So apart from this case, little later, right here, little later, I will even explain this also. See, this also I will explain. Okay. Make a note here. See, as per this sketch, this is the base. See, base is defined. And for the base, height defined. Base, height defined. This way, see, horizontally base defined, height is vertically placed here. Here, vertically, base is not defined. See here, for full triangle, vertically there is no base. Therefore, B is the base, H is the height. Here also same thing. But here, see, I will call it later, B is the base, this is the height. Here, base is vertically defined, see, B. This is height. Here, horizontally no base. I will come to this little later. You make a note, this also will come. I told you everything explaining. Okay, start. Now, you put the two sketches here. B, H, B, H. B means base, B means base, H means height. Now I will not write every time. Now, I told this perpendicular from vertex divide into two parts. B1 and B2, B1 and B2. They are not equal. Make a note here. Triangle in general means B1 not equal to, not there. See, triangle in general means you can write here. Triangle in general means later B1 is not equal to B2. But if B1 becomes equal to B2, it will become isosceles triangle, that is second round. Someone will tell, why B1 cannot be equal to B2? In general triangle, I am taking the case when B1 B2 are not equal. Can't you hear what I told? If B1 equal to B2, that comes in second case, isosceles triangle. Learn mathematics first. Okay. Start now. This is one or this case. See here. B1 can be more or B2 can be more. Any one can be more. But for some reason, I want which is more. So right here, this case, in the first sketch, he made B2 more. B1, see, right side more distance, B2. Second case, he made B1 more. There's a reason for it. Okay, start. Right, for this sketch, B2 more than B1, see, answer is here. For this case, see, answer is here. Now see correctly. Base B, height H. Base B, height H. Area equal to half into base into height. Now, centroid. See here. I already told for a triangle, if base and height are properly defined, centroid along the height measured from the base is 1/3 of height, from vertex 2/3 of height, or in these two sketches, this way centroid directly you can mark. Now 1 minute here, this is a vertex. See, observe whether centroid will be, I want to mark this way centroid along the height. More area is bottom side, see, spread here. So centroid will be down. Now doubt comes, is it here or here? It will be somewhere here. I will tell the reason for you. Later I will tell you, 1 minute. Right now you worry about location of centroid along the height. See, here it will be on the right side portion. Here it will be on the left side portion. Why means I will tell you it later. I will explain to you, don't worry. This is centroid G, centroid G. Now see, I told along the height, centroid is near to the base. G, 1 minute, G here, G. Here also, see. G. So therefore, slightly out of scale, okay, no problem. Who will bother that much about scale? See, shape or sometimes straight line. So this will be, make a note here, 1/3 of H. From here, it will be 2/3 of H. There are people who will tell, little more is there. People who comment, they will tell, don't know how to mark 1/3, 2/3. See, comment. If I measure this distance, see, little extra is there. See, does not know geometry. Let them comment. Foolish comments. Okay. I am not going to measure the scale here. Here also, see, this will be 1 by 3 of h. See, all green color. This will be 2 by 3 of h. Okay. Along the height over, along the base, there is a standard formula for this one. So many are not knowing. I already derived it here. See, centroidal distance along the base from here will be full length plus this cut length divided by 3. Full base plus this side base divided by 3 from here. Full base plus this side cut base. Some will tell there is no cut base. I am telling cut base is there. See, again, see people who are commenting. People are there, does not know how to project properly and is taking classes. Okay, I will stop this one now. But it is not irritating me. But I am getting angry because people without knowing anything, they don't know even this much. I should tell, compared to, bro, I don't want to tell. How much knowledge I have got, the one who commented will, no, leave it. I will ask him, that person. I uploaded some classes on brain teaser, answer them. Then I will agree you have got talent. Okay. No, sorry, now onwards, I won't tell. Take a joke. Okay. 1 by 3h out. Now, see this way. But now, doubt comes, this side or that side. See, come to the junction here. See, right here, you come to the junction. Both the places come to the junction. See, where more area is there. Left side more area, right side more area. Somebody on the road will tell, sir, this side more area. Oh, yes. Since this side more area, centroid will jump to that side. Okay, that's why this side, right here. Centroid is this side because huge area is there here. Here, this side more area is there. Centroid jumped here. Make a note. This is all I explained. That's why you should write notes or go through the class repeatedly. Once you understand everything, rewind a little. Again go through till firm. Now formula is very simple. Whether centroid lies this side or that side, formula is same. What is the formula? Full length plus where you stand, that side cut length. Full length B. Again comment. It is not length. It is the base. Okay, when you base correct, when you measure it is a length only. Okay, what to do? Sorry, I should not tell. Full base plus cut base. B1 divided by 3. From there, out of scale, full base plus cut base divided by 3. Full base plus cut base divided by 3. Full base plus cut base. B2 divided by 3. Okay. This will give, now see, this is the centroidal location. These are the axes passing to centroid. These are called centroidal axis. Later we'll call XX, YY, etc. Not required today. Over. Now, make a note. You write this much neatly write. Then below, see, I am writing here only because time saving. This much you make a neat fair copy. Then further below, sir, where to write further below? Here I can't write. You in the paper you select somewhere upper side, leave space bottom side. There you make a note. Note. By chance, you write there. By chance. Sorry, not by chance. Suppose this is a loading diagram. Imagine this is a loading diagram. Uniformly varying load is there. You forget the formula that B plus B1 by 3, etc. like that. Then what you can do is make a note. Those who find difficulty for this centroid problem, that special formula, that full length plus cut length, whether coming here or coming there, if confusion is there, make a note here. You divide into two triangles, right angle triangle. See, one here, one here. Divide into two. to right angle triangle. See, this way. Then right angle triangle, later I'm explaining, so you believe me. Then for this you take this as part 1 and part 2. Take this as part 1 and part 2. Then centroid for this will be, see, for this triangle, later I am explaining for you, so right now you believe here. See, this is the centroid G1. This is the centroid G2 here. This is the centroid G1. This is the centroid G2. Then this area equal to half into B1 into H. This area equal to half into B2 into H. This area, see, I am writing everything. This area half into B1 into H. This area half into B2 into H. And later I will explain to you, this is and this one and this one, little out of scale. Okay, little that side. Okay, no problem. This is 2 by 3 of B1. This is 1 by 3 of B1. This is 1 by 3 of B2. This is 2 by 3 of B2. It will come a little later, and height wise, this is H, 1/3 H. This also H, this is 1/3 H. Even this also is, see, 1/3 H. This is 2/3 H. Here, see. Now here, see, 2/3, 1/3. See here. This is 2 by 3 of P1. It will be explained little later. You wait for some time. 1 by 3 of B1. Again, this is 1 by 3 of B1. This is, by looking only you can make out 2 by 3 of B1. This is G1, correct. Even G1, G2, for both of them, 1 by 3H and 2 by 3. Here also same thing. Don't write common. See, this is common for both. Here height H, here also height H. For both of them, 1/3, 2/3, both place not required, one place sufficient. You make this note. For this triangle, when I placed horizontally base and vertically height. Now, by chance, when you do a question of moment of inertia, then you have to divide like this, because about this axis, about that axis I told, there is no formula or expression for moment of inertia. So dividing is better. But in structural engineering, I will give one more example for you. When to divide, when not to divide. When you can do it without dividing, better. Still there, if you want, you can divide. See, this is your option. Okay. It will come slowly later. In the next class, it will come. I will give one more class for the types of loads. One final touch I am giving. Okay. You make all this note. Then, okay, 1 minute now. I will write here only. I don't want to pause. 1 nimisha. Okay. That's a Kannada word I used. 1 nimisha. Actually, my mother tongue is Kannada. Same statement once again. You write some extra now. Actually, I don't want to repeatedly pause the recording. Later, joining becomes difficult. The more and more parts I divide, later it will take video merger, will take more and more time to join. Sometimes it will refuse. It will tell number of files are too much. It happened once. So now see, one special note you make here. I will finish that one now. Okay, now, first make a note. Just now we completed when the base is horizontal, height is vertical. Or it is possible that, see, it can be like this. It can be like this also. Or it can be like this. Sorry. Anyone bigger, no problem. See, this is base. This is base. This is the base. This is height. H. Height. This is vertex. Vertex or space problem, I write here. This is one more. It can be this way also. This is base. B stands for base. This is height. Some will ask, why not this side? Some side. This is vertex. Then, if I draw perpendicular here, let this be, anyone you can call B1. Let it be B1, your choice. When I derived earlier, I don't know how I derived. You don't bother about old one, B1, B2. Or okay, I will put bottom B1. From bottom I will start. From here, you are first seeing B1. This is B1. This is B2 here. Little more space required. This is base B. B is the base. Let it be B1. Let it be B2. Here space is not there. This is the case when B1 is more than B2. See here. Or this is the case when B2 is more than B1. Write this way. Or here only write. This is the case when B2 is more than B1. Now, for this case, see, for this case, I will write here all properties first. I will finish. Then I will go to this case. Space problem is there. I told this case, that is when your B1 is more than B2. See. Vertex here. Okay. No, I can go furthermore. Okay. Furthermore, I can go. 1 minute. I'll complete first. See, full base B. Now see, now you tell here, vertically base, horizontally height. Horizontally base is not defined. You write there. Horizontally base is not defined. Okay. B, somewhere write H. Okay, he'll write it here. H. This is height. H. Then see. This is B1, that is B2. I am taking what? Oh, no. Completely gone. Oh, okay, no problem. What is there? What? These all happen, see, human being, these are not mistake. I did not see properly. Okay. Again, comment will come. B1 and B2. B2. Okay. Height H over area first. Half into base into height. Okay. If I forget, leave it. Now, this way centroid. See, it will centroid will be somewhere here. Centroid G. So therefore, little this side. Okay, Nisha. Little this side. Okay. Centroid G is here. See, centroid along the height is 1 by 3, 2 by 3. Where more area? This side more area. So, if I draw a light vertical line here, I can mark there. I will mark here now. Space problem. This is 1 by 3 of H. This is 2 by 3 of H. Whereas centroid along the base, see here, I told you come to the junction. Oh, lesser area that side, more area this side. Where area is more, centroid will lie. B1 more than B2 means centroid will lie on the B1 side. So centroid will lie here. From here to here, formula is full base B plus cut base B1 divided by 3. From here, if you want centroidal distance, see, full base B cut base B2 divided by 3. Make this note. Okay, now do one thing. Once you make this note, immediately below, somewhere below, make one note, extra note. Make one extra note. Suppose this purpose is moment of inertia. If you take this way, see, there is no formula for moment of inertia here. So, or those who find difficulty, you do one thing, you write here. One more sketch you require, one more sketch. Divide into two right angle triangles, see. Then, this, I will call this as figure number 1, this is figure number 2. This area equal to half into B1 into H. This area equal to half into B2 into H. And this way centroid for both of them. See, centroid will be here, centroid will be here. This is your G2, this is your G1. For both of them, see, yes, this way 1 by 3, 2 by 3, 1 by 3, 2 by 3. This is G1, 2 by 3. But this way, separately write, this is, see, 2 by 3 of B2. Little later, I am explaining for right angle triangle. This is 1/3 of B2. Little down actually, okay, little down. Why? Because area is more, G1, little down. This is 1 by 3 of B1. This is out of scale, 2 by 3 of B1. Make a note. Those who find difficulty, you can do this way. Okay, now, this case I covered. Now I will take up the case of B2 more than B1. Right now only, in a single stretch. So that easy for me later. Okay, now, everything you write, so that it becomes crystal clear for you. See, now consider the case of, that's already over. See here, when B2 is more than B1, right here. When B2 is more than B1, see what happens for this sketch. See. B2 more. Okay. This full is base B. Base B. This is height H. H. Area equal to half into base into height. Now, centroid this way is 1/3, 2/3. This way, now your, I wrote it. This is your B2, which is more than B1. Since B2 is more than B1, this way is 1/3, 2/3. This way, it will be lying where area is more. So, centroid will now come somewhere here. See, it's not that much actually. Okay, centroid here G, common for both. And now, see, along the height, 1 by 3 of H, and from here 2 by 3 of H, and along the base this way from here, oh, projection problem, not proper. See, comment will come later. See, not closed properly. See, again for comment's sake. I told I am not telling again and again, but it actually comes to my mind how it is possible. First of all, okay, start. If you want from here, it is full triangle. See, I am writing CG for centroid for, see, some rare cases, centroid is also called CG. There is no question of offense, because when you derive centroid, first you consider center of gravity of thickness equal to T, uniform thickness, then that center of gravity will change over to centroid if you know subject properly. So from here, full base B plus B2 by 3, here B plus B1 by 3 is the answer. Okay, make this note. Then somewhere right side, make an extra note. By chance, this difficulty is there for all these complications, then what you do is, see, divide into, see, divide into two triangles. See, two right angle triangles. This will come little later. Okay, then you call this as 1, your choice. Figure 1, figure 2, any one figure 1. Figure 1 area equal to half into B1 into H. Figure 2 area equal to half into B2 into H. Okay, then centroid this way is standard. See, this is your G1, this is your G2. So this is, the height is H, 1/3 H, 2/3 H. Height is H, 1/3 H, 2 by H common. But this way, see, from right angle triangle, for this triangle from here, this is 2/3 of, oh, this is B1, B2 are gone, this is B2, this is B1, okay. 2/3 of B2, this is 1/3 of B2. From here to here, space problem, 1/3 of B1. From here to here, 2/3 of B1. Make this note. Okay. Now everything is over. Now I will go for numerical part, little bigger. I will prepare first, time saving. Numerical means no question of A, B, C, D like that. Full numerical. Okay. Just a minute. Now, 4 numerical examples. I don't have to explain too much now. Pretty fast I will do. 1, 2, 3, 4. See, 1. Base 150. Little small I written here. If anything is not visible, you can see here. Or a little zoom. Base 150. 55. Total 150. If it is 55, from 150 subtract 55, you will get 95. So I am rounding off. Rounding means calculated. All dimensions in millimeter. I told I am not telling once again. If someone tells dimension not there means no problem. Let him not study from my class. Okay, start. First centroid this way. This is the base. This is the height. Along height 1/3, 2/3. Already explained. My answer is not required. Over. Along the base, oh, more area is that side. So centroid will come here. From here, full base 150, cut base 55 divided by 3. From there, full base 150, cut base 95. See, cut base is my word to understand. Divided by 3. 1. You make a neat note. Then make a note. One note you write here. Or suppose this is a loading diagram and later you have problem for this locating centroid on. If difficulty is there, what you can do is you divide into 2 right angle triangles. See, separate. Okay, I will take this as 1. For the 1, area equal to half into 55 into 75. I won't write unit also, that much square, write it. This I will take 2, area equal to half into 95 into height is 75, square. Okay. Centroid. Later I told, see, if anybody confusion is there for right angle triangle, you wait for little time. Next I am doing isosceles triangle, very, very simple, 2 minutes work. When I go to right angle triangle, full board, I am giving 4 cases for you, 4 questions. Therefore, understand, then again come back here. Okay, see, for this one, centroid is here. So it will actually, okay, centroid here. For this one, centroid here. This is your G1, this is your G2. See, height wise, same thing. 1/3, see, for this base, height is 75. Here, for this base, height is 75. So height wise, 1/3, 2/3 for both. For both G1 and G2, it is common. See, okay. Little here. Okay, these small things you don't bother. Same. But Along the base, cut, see, from here to here will be this point, it's out of scale, okay, no problem. This is 2/3 of 55. Don't measure, it is near this side, 1/3 of 55. Whereas here, from here to here, 1/3 of 95, here to here, 2/3 of 95 is the answer. You make this note. Okay, now I will go to one is over, example 2. I will top this one now. Okay, I will do single stretch. I don't want to pause. $200, $130. Okay, see. $130. This is 200 is 70. Okay, now correct. Okay, height 110. Height is, it is this side, space problem, 110. This cut base is 130. If that is 130, you calculate this cut base, total given is 200. 200, correct? Huh? 200. Cut, remove it, it becomes 70. Calculated value. Now, for this base, or for here, height-wise, height is 110. So this way, 1/3. Centroid will be somewhere here. Somewhere here. Why this side I will tell you later. Somewhere here is centroid. G. This is for the entire lamina, no dividing into parts. If I project height-wise, see, height-wise, this is 1/3 of edge. This is 2/3 of edge. Remember, by chance, if the lamina is this way, then this will be 1/3, this will be 2/3. That I will explain in the problems later. Okay. Now, lengthwise, see, come to junction. Oh, there is more area this side. Why? Base 130 is there. Where base, cut base is more, centroid lies there. So this distance is full base 200 plus the cut base 130 divided by 3. This distance is full base 200 plus cut base 70 divided by 3. And area I wrote, okay, forgot area. Area for the full triangle is, if I forget you write, half into 200 into 110. Comment will come. You need not written. You write if you want. Over. Vertex all I am not writing. I told you vertex all. Now make a note. By chance, you do not like this cut formulas. Then you can do one thing. Divide into two triangles, two right angle triangles, this solid line, divide here. Then this is one right angle triangle, this is other right angle triangle. Then for this base, height is 110. For this base, height 110. So for both of them, height wise 1/3. So where? Maybe somewhere here. Okay, somewhere here. This is your G1. This is your G2. See, you call this as figure number 1. This is figure number 2. For this one, area equal to, I should not write, half into 130 into 110. For this area equal to half into 70 into 110. By chance, when I write, if some number is missing, suppose the wrong number entered, you correct it. Don't make an issue of it. Okay. Now, this way is over. This way distance, see, from here to here will be, CG is this side, centroid or center of gravity. Centroid will tell. This is 2 by, because right angle triangle, 2 by 3 of 130. This is 1 by 3 of 130. Here, this will be 1 by 3 of 130. You have to wait for little time when I go to right angle triangle. Sorry, not 130. See, by mistake, 1/3 of 70. Such things happen sometimes. 2/3 of 70 over. This is the answer if you divide into parts. Okay. Which one over? Question 2 over. I will go to now only numerical example 3. 3 and 4 stretch I will do it. See, people should understand. You should see my age. I will tell you, I am 67 years, but I still feel I am not above 40. When it comes to mental feeling, I feel I am very young, physically old. You should think that way. When he is question example, see, this also over. Now third question, third example. When this much is giving effort, you should think, we should utilize it. So much and so much is explaining, and you have to utilize it now. 115, 180. Okay, scale I am not bothered too much. Height is 80. Okay. This is the example, little more. Okay, understood? 115, it is lesser. Okay, okay. See, I am not dividing into parts. I am taking full triangle. Then the full base is how much? 180. Whereas this cut base up to here is, okay, they are told this is 115. If this is 115, from 180 subtract 115, it will be 65. Correct? 65, 75, correct. 65. See, when I want to count something, I can do it only in my mother tongue language, Kannada. And this height, see, it slightly came this way. Okay, don't make issue. When I see so much I am writing, sometimes slightly tilted here. You do one thing. You tilt this way and see, read. You turn your mobile or laptop slightly and read. These things you should not bother too much. 80. Okay, now see. This is the base. This is the height. Along height, from this side more area. This side 1/3, that side 2/3. And now, this way, this is bigger, that is smaller. So centroid will come somewhere here. It will come this side, G, for the entire lamina. If I project that one here, see, this is 1 by 3 of height 80. This is 2 by 3 of 80. Okay, now, this way, from here, full length 180 plus cut length 65 divided by 3. If you want from here, it is full length 180, space problem, I'll put this side, okay. If I want this distance, see. Full base 180 plus this cut side base 115 divided by 3. Make this now. Area I forgot right. If I forget you write, area for triangle equal to half into base is 180 and height is 80 mm square. Over. Again, earlier when he wrote area, he rounded. This time not rounded. Don't comment that way. No. Make a note now. After everything is over, make a note. Suppose you do not like this way, that I don't want that cut, etc. Then do one thing, make a note. Same thing, divide into 2 right angle triangles. See? Anyone, you take this as 1 and take this as 2. For this area equal to half into 65 into 80. For this one area equal to half into 115 into 80. Okay, millimeter square. Now centroid independently. See, this is centroid G1 cut. I am using black color now. Okay, green also will do. Centroid G1 green color. This is your centroid G2. No, this is G1, that is G2. See, for this base height 80, for this base height 80. So height wise for both of them Answer is 1/3, 2/3. But along the base, see here, this is from here to here. This is a right angle triangle now. See, for this base, this is the height. This is 2/3 of 65. This is 1/3 of 65. And then this is 1/3 of 115. This is 2/3 of 115. Make this note. Okay, over. Now, last case, fourth one. Full base is how much? 300. But here changes. Sometimes I feel like rubbing my hand only. Why? Lazy to go there and bring the cloth. I can wash my hands. It is not a big issue. Okay. See. Full base 300. 110 go smaller. Not bigger. Almost that is double. Almost double. Okay. Height 105. Okay. Okay. That's out of scale. Oh, if I write here, there is no place to write distances here. Okay, 1 minute. Here. 300 full base. 110. Okay. This is 190. How? From 300 subtract 110. See, I am putting dotted line. Why? Because I am not dividing into parts. So, dotted line. This height, write somewhere here. For this base height, 105. 105. Okay. Then, for the entire triangle area, half into 300 into 105 mm square. I am not rounding off this time. Let the people comment. Then, this is the base. This is the height. Now, this is 190. So, centroid will be this side and this near here. So, centroid is somewhere here. For the complete lamina, this is centroid for the entire lamina. See, this way is 1/3 of how much? 105. This way from there is 2/3 of 105. But this way, centroid will be this side. Okay. This distance is full base 300 plus cut base 190 divided by 3. This base, this from here, it is full base 300 plus cut base 110 divided by 3. I am not explaining much because earlier told, long back told, derived, explained there, 8-10 times I explained, again just now sketches explained. Still if it is not clear, what I can do? Okay, make this note. Now, for the same sketch, make a note. By chance, you do not want this formula. See, if it is a moment of inertia question, you have to divide into two triangles, no other way. Okay, this is one triangle, this is other triangle. Call this as triangle 1, call this as part 2. For this area equal to half into 110 into height is 105. For this area equal to half into 190 into 105 mm square. Centroid, this C, for this base, right angle triangle, for this base height, how much? 105. For this base also height 105. So, for both of them, centroid this way will be same, constant. Okay, see, this here you call G1, this I will call G2. Both of them 1/3, 2/3. But this way, see here, from here to here, and from here to here, and from here to here, here to here. For this base height here, 2/3 of 190, 1/3 of 190 here, 1/3 of 190. The small I am writing, I am dictating. You can listen and write. 2 by 3 of, sorry, not 190, see, 110, 110. These are 2/3 and 1/3 of 190, 1/3 and 2/3 of 110. Make this note. Triangle in general is over. Now only I will do one thing, because a right angle triangle, big sketch I require. Therefore, to save the time, right now I am going for case 2. It will take only half minute. Not half minute, 5 minutes, that's all. Case drawing, I write here, triangle is continued. Triangle continued. Now we are going for case 2, isosceles triangle. Spelling I am not bothered too much, I think correct. Sometimes I get doubt. Okay, isosceles triangle. Okay, 2 cases are there, see. It can be like this, or I will take one more case, it can be like this. Okay, here, this is the base, this is the height, B becomes base, H becomes height. And here also, this is the base, B, this is base. I should check the camera once. This is the height. This is vertex. Here this base, this is vertex. Now, if I put dotted line here, this is base, these two are equal. See, this is B by 2 and B by 2. Here, if I bring it here, isosceles triangle means what? These two triangle has got same base, same height, and this angle equal this angle. That much mathematics you should be knowing. 1 minute. Okay, no problem. Okay, now I'll finish. For this one, see, for this one, answer I will write here. Now divide, this time don't divide. Why don't divide? Isosceles triangle, why won't divide? Height H, base B, little further, base B. And if you draw a line here, this is B by 2, B by 2, equal, B by 2. So area equal to half into base into height. Centroid. See, now make a note. This is axis of symmetry. See here. This is axis of symmetry. Oh, therefore, centroid will lie here. So, therefore, this way, centroidal distance will be, space is this side is there. I will project here. See, height is this way. So, from base it is 1 by 3h. This is 2 by 3h. Whereas this is g. This way not required. Direct answer. Actually B by 2. That is a black color. I will put a blue color. B by 2, B by 2. Some will tell. Already there. Already there as a dimension. Now there as a value for centroid location. Okay. This is one case. Now, over. Second case. Over. No, don't divide into parts now. Now someone will tell, suppose you divide into parts, why you have no other work to do? Then do one thing. If rectangle is given, I will tell, divide into 100 rectangles. I will tell that way. If a rectangle is given, divide into 1000 rectangles. Okay. Now I will come to this case. This case. If it is this case, right here. Okay, I'm done. This is the base. I won't explain much now. Base. This is the height. If I project here, this will be B by 2. This also B by 2. Don't bother about scale or what. Okay, this is actually sometime happens. See, it is getting late in the night now. Okay, b by 2, b by 2. Some will tell does not look equal. Okay. Now, this is the base or area. I forget sometime area. Half into base into height. For this base, this is height. So, and one more thing, see, now this is your axis of symmetry. Axis of symmetry. Therefore, centroid will lie here. This way, see, last time, this way 1/3, 2/3, this way midpoint. Now, this way 1/3, 2/3. 1/3 of h from here to here is 2/3 of h is centroid G, whereas this way, don't calculate, it directly b by 2 and b by 2. Exactly center. Okay, this also over. Now, single stretch I am doing. Actually, numerical example is not required. So, isosceles triangle, I'll give 2 numerical examples now. Okay. Single stretch, I'll do it. See. 2 examples, numerical examples, right? 1. Okay. This is base is horizontal base, you write here, of 80, height of 50, and from here to here is 40 given. Second example is this way. Second example, this way. This base is anything, 125. 125. In the question given, this is 62.5. And this height is anything, say 90. Okay. Now, example 1. Sufficient. Both I can cover. Single stretch. See. Height. How much? 50. Full base 80. Therefore, area. Area equal to half into 80 into 50. Then, this is your axis of symmetry. Right here, correctly. Axis of symmetry. Centroid will be here. So, this way if you project, this will be, okay, I want the space there, I'll write here. If you project this way, this will be 50. Go this side. 50, you come here. 50, you go there. This 50, you come little this side. Space problem, 50. This is, again same thing, projection problem. Don't make issue. 1/3 of 50 from here will be 2/3 of 50, whereas this way don't calculate, it is exactly centroid. 80 means, see, it is question given 80, one more thing. In the question given, this is 80, also given, this is 40, this is 40, out of scale, slightly gone out of scale, please manage it. Now I can't change anything, feeling tired. 40, 40 they told, 40, 40 they told. If that is 40, this is also 40 only, calculated. Centroid is 40, 40. Over. Now, example 2, I will do here. See. Space problem, available space, this way. 125 base, okay, right here. This base is 125, okay. 125 base. Little this side, okay. 125 base, exact center is 62.5 here. This is 62.5. This also 62.5. That is isosceles triangle where height 90. Okay. Where, what you can tell? Where base is vertical. That's all. This is all same point. Okay. Okay. Base is vertical. Area. Half into 125 into height. I write somewhere here. Height is 90. 125 to 90. Now, this is your axis of symmetry. See, right here, axis of symmetry. Centroid lies here, G. So, this way, no location required. Directly given value only. that is 62.5 and 62.5 or 125 by 2. But this way, along the height, this is 1 by 3 of 90. From here, 2 by 3 of 90. Okay, over. This will complete isosceles triangle, right angle triangle, full board. I want to write something because that is the most critical, right angle triangle. Now come to the most important part of the triangle, case 3, right angle triangle. Now, completely understand. Let x naught, y naught. See, I don't call base and height now because right angle triangle, if this becomes base, this becomes height. If this becomes height, this becomes base. So I do not want base and height. Like rectangle, let x, somebody may tell, why don't you call base and height? I do not want to call. My purpose is to make it clear for you, not by heart some formula. Let x naught and y naught be the two sides perpendicular to each other. And among them, let x naught be horizontal and y naught be vertical. Means, I will take 4 different sketches now. Everywhere, x naught is horizontal, y naught is vertical. Okay, now, little later, I will come to numerical example. Consider a right angle triangle 200 mm by 140 mm. Be the two sides perpendicular to each other. Now, there, let 200 be horizontal and 140 be vertical. Okay, now see, my usual problem. I will first do this case, general case, that is in terms of x naught, y naught, then I will go to numerical. If I rub everything now, see, my problem, I am not good in by hearting. I cannot remember numericals, only principles and what you call principles or what you can call is the concept I remember, sufficient for me. So I made a note here, see, you cannot see it, 200 horizontal, otherwise, again I start wondering now, how much I have given, how much I have given, okay. Sometimes people laugh at me also, so fast you forget. Somebody in my native told me once, if you forget so fast, how you take the classes? I told, come to the class and see. Okay, now, first I'll do one thing now. I will pause the recording now for some time and write the sketches, then start to save the time. Otherwise, because very, very neatly I have to write. I'll just pause for little time. Okay. Anyway, you can't make out the pausing all. Why? When I start, you can see there. Start. First, I will take 4 possibilities. See, right angle triangle can be like this, or like this, or like this, or like this. So that nobody can tell this is not done. See, everywhere. Here, horizontal side x naught, vertical y naught, common for both. See, I written in between. Horizontal x naught, vertical y naught. Horizontal x naught, vertical y naught. Again, horizontal x naught, vertical y naught, common for both. Horizontal x naught here, vertical y naught here. For all the cases, area equal to half into x naught into y naught, or you can tell your choice, depending upon how you are seeing. Sometimes people tell, sir, base I want first, or half into y naught into x naught, whatever way you want. Okay, area over. Now, see, divide the base. See, now, one most important, everywhere. If x, everywhere, make a note. If x naught is the base, y naught is the height. X naught base, y naught height. X naught base, y naught height. X naught base, y naught height. Or, if y naught is the base, x naught is the height. When y naught is the base, x naught is the height. Distance of centroid along the height is 1/3, 2/3. That way. So, if you take base x naught, then from the base, this way distance is along the height y naught, 1/3, 2/3, 1/3, 2/3. Here, this side, 1/3, 2/3, 1/3, 2/3. But now, incomplete. 1/3 or 2/3 of x naught. This is 1/3 or 2/3 of y naught. 1/3 or 2/3 of y naught of y naught. 1/3 of x naught, 2/3 of x naught. 1/3 of x naught, 2/3 of x naught. Everything here. 1/3 of y naught, 2/3 of y naught, 1/3 of y naught, 2/3 of y naught. Now, if confusion is there, see now, any one triangle, this way centroid, there is more area on the right side. So, see, centroid will be near to right side. So, lesser, bigger. Nearer means what? Lesser distance. This way centroid, downside more area. So, downside 1/3, upper side 2/3. See here. Here, left side more area, 1/3, right, see left, more area on the left side. See, he can see opening here, see, 1/3, 2/3. Here, more area on the bottom side. So, bottom 1/3, top 2/3. Yeah. More area on the right side. So, 1/3, 2/3. More area on the upper side. See, here lower side, here upper side, 1/3, 2/3. More area upper side, 1/3, 2/3. More area left side, 1/3, 2/3. Or, I will tell one more thing. Right angle triangle, what you can do is divide the base into this side into 3 equal parts. Everywhere, 3 equal parts. Come to the point where 90 degrees there. Make a note if you want. Make a 90 degrees there. From 90 degree, the nearest points, either side, see, nearest point here, nearest point here, see, here. From 90 degree here, see, nearest point here, nearest division, this point. 90 degree, nearest here, nearest here, nearest here means this point. From 90 degree, nearest here and nearest here, that is this one. So, if you measure from the point where 90 degrees is there, it is always 1/3. If you measure from the vertex, see, their vertex, it is, see, for this base, that is vertex. For this base, this is vertex. Then it is 2/3. So, correctly understand, sufficient. Now, more example come. Now, come to numerical example. Very easy, because numerical example. All dimensions millimeter. See, I told horizontal is 200 millimeter. Vertical is, I told, 140. Yes, you should not do this way. You are write once again. You should not write like this. I will advise you to write once again 200 base, height 140, 200, 140, 200, 140, 200, 140. Now see. For all the 4 cases, area equal to half into 200 into 140, or you can write half into 140 into 200. Whatever you want, you can do it. Centroid, see now. This way, near this side, 1/3 of 200, 2/3 of 200, 1/3 of 140, 2/3 of 140, 1/3 of this way, 140, 2/3 of 140, 1/3 of 200, 2/3 of 200, 1/3 of height this way, 140, 2/3 of 140, 1/3 of 140, 2/3 of 140, 1/3 of 200, 2/3 of 200. Everything clear? 2/3, 2/3, 1/3, 1/3, 2/3, 2/3, 1/3, 1/3, 2/3, 1/3. Oh, here not written, forgotten. See, last time I forgot right here. Okay, last time you write here, forgotten. Earlier case you write 1/3 of x naught, and I forgot right. Okay, 2/3 of x naught. Actually here, that is earlier case. Now write 1/3 of 200 and 2/3 of 200. So, forgotten. Actually, same base, same thing it becomes. This is centroid for right angle triangle. As I do more and more problem, up to some limit, I will again and again explain to you this one, till you get perfection. Okay, now, right angle triangle is over, 2/3, 1/3, 2/3. I am searching for mistakes. Someone will tell wrong distances. 2/3, 1/3, 1/3, 2/3, 1/3, 2/3, 1/3, 2/3, 2/3, 1/3, 1/3, 2/3, 2/3, 1/3. People are there, people who want to comment. They are genius people. Okay. This one, correctly understand this one. Now I will go to next part, that is trapezium. Okay. Not too much explanation, little limited explanation, but some word statements are there. Okay, now we will consider trapezium. Some dictation I am giving. First of all, note, if the trapezium is part of a lamina where other parts are there, then the standard expressions we will not use. Because when you find moment of inertia, there is no formula for moment of inertia for a trapezium. Of course, can be derived, but nobody is using it. Then you divide into either a rectangle with the two triangles, or sometime rectangle with one triangle. But in structural engineering, so many places you get trapezium. One important is uniformly varying load in the form of a trapezium. There, what I am giving today is very, very important. Or sometime you get pressure diagram for footing. Or so many places you get trapezoidal area, see, dam section, etc. There, the expression I am going to give is very useful. So, as far as our continuation of centroid and moment of inertia, what I am giving now is not of much use, but remember, what I am giving now is very powerful later. So, study everything. First of all, make a note. For a trapezium, there are two parallel sides. I will tell only once, these are all told earlier. You should go back to earlier classes. The two parallel sides can be horizontal placed. Then between them distance is vertical. Parallel sides, I will tell you, see, I put arrow mark here. Arrow mark means parallel sides. See, parallel sides B1, B2, this way. H is the distance, see, B1, B2 are the two parallel sides. H is the perpendicular distance between the two sides, H. Now, see here, which among B1, B2, which is bigger, which is smaller, does not matter. But it matters when you mark centroid, slightly mark towards that side where area is more. I will tell you later. Okay, now, see, two parallel sides can be horizontal, or then vertical becomes height, or height, not height, perpendicular distance between the parallel sides. Or see, first round here. Second round, see, parallel sides are this way, vertical. That is B1, B2. Anyone can be bigger. Then between them distance is H, perpendicular distance. Or you can do one thing. These you can see, this you can call base, height. See here, base, height. Even that also is base only. Bottom base, top base. Okay, base, height. See here, base. Here base is vertical. Height horizontal, base, height, base, height, that way. So you can make a note. Now, to locate centroid, you require one distance along the base and one distance along the height. Our standard expression, see, make a note here, standard expression for locating centroid, you have to write big letters. For a trapezium is only the distance from any one of the parallel sides, or it, that is either from B1 or from B2. Space is not there, right? Either from B1 or from B2. See, from B1, this distance means, or it is distance from B1, B2, but the distance is along H. The distance is always along the height or measurement from the base, any or parallel side. But the distance is perpendicular to it. See, you know it. If you measure from a vertical side, distance is horizontal. If you measure from horizontal side, distance vertical. Here, parallel sides are horizontal. So, formula is for vertical distance in all these three cases. Here, parallel sides are vertical. Measure from the parallel side, but distance is horizontal. Now, see there. I have written so many sketches here. A trapezium where both sides offsets are there. See, triangle, if you divide into parts, triangle, rectangle, triangle. Here, right side rectangle, left side triangle, that's all. Here, left side rectangle, right side triangle. Here, center rectangle, upper side triangle, lower side triangle. Oh, both are same. Both are same. Oh, I don't know what happened here. One minute. Okay, I'll change it. Both are same. Okay. Sometime it happens. Okay. Okay, now correct. Okay, now G will be. Okay, I'll manage it. These are, don't bother about these things. Sometime it happens. Okay, G. Now correct. Upper side rectangle, lower side triangle, upper side triangle, lower side rectangle. That does not matter. For standard formula, whether it is this way, among the 6 cases here, it can be anything. See, when you apply standard formula, what are the offsets of one side with respect to other does not matter. You write in the standard expression for location of centroid, B1 will come, B2 will come, H will come. That offsets all will not come. Those offsets will come if you want to locate centroid along the base, this way. See, if this way means if you want to locate, then the offset will come here. If you want to locate this way, then the offsets are required. Now, I will tell one thing. Right mark means, see, in the class here, okay, I write here now. Now, if I put right mark, it means standard expression available. Standard expression available. I will give it available. Question mark means sorry, no standard expression. No standard expression. Then how to get it? You have to divide into parts and do it, which I already explained earlier. See, earlier these are all solved. This is only recap, but powerful recap. So remember here, see, along the height, right means there. This way, not there. In all these 3 cases, height is this way formula is there, this way formula is not there. First you write all these things neatly. Okay, now I'll give standard formula for trapezium. One special case is there. Last I will tell it. Yep. Okay, now I will give by words. First of all, remember area of a trapezium. You should know it. Area of a trapezium equal to sum of the parallel sides. I will put parallel this way to save time. Sum of the parallel sides divided by 2, that actually means average parallel side, multiplied by distance between parallel sides. Distance between parallel, distance means perpendicular distance between parallel sides, or equal to sum of the parallel side is B1 plus B2 in all the 6 cases. divided by 2 into H. This is all the 6 cases you write there. It's coming later. I won't write area once again. Now all 6 cases I am writing once again now. For all the 6 cases, area if you want, sum of the parallel sides divided by 2 into height. Okay, this over. Same thing I cannot tell how 10-15 times. Now next very important words. Distance of centroid from, I told standard formula is for distance from one of the parallel sides, from any one of the parallel sides, any one of the parallel sides, any one of the parallel sides is equal to, see, that parallel side, to save time, that parallel side, from which side you want to measure, that parallel side plus 2 times or twice of other parallel side divided by sum of the parallel sides, sum of the 2 parallel sides multiplied by perpendicular distance between the parallel sides, remember, divided by 3 is the expression for location of centroid for a trapezium only when the centroid is located with respect to one of the parallel side or along the height h. Okay, now I will not tell. Sufficient. Okay, now do one thing. I will give formula now for all the cases. See, to save time, I told just now the offset does not matter. I already told just now, offset does not matter. See now. So therefore, to save time now, I will do one thing now. See, imagine trapezium like this, randomly, this way, or trapezium this way. Left side projection, right side is not there, or right side projection does not matter. See, I will take, this is B1, this is B2, B1, B2, B1, B2. Now, there is more area this side. So, centroid. This way we don't know, I told you. I told everywhere this is H. This is H. This is H. This is H. Therefore, you can mark this distance from here, see H, this distance or this distance. Here, centroid may be somewhere here, okay. You can get this distance or this distance. See, that little more, that you can make out later. Here, okay. Centroid G, this distance or this distance. You write neatly all the sketches. See, this distance equal to start here. I want to measure, I put here now space problem. Okay, I want to measure distance from this parallel side. So start that parallel side B1 plus twice of other parallel side B2 divided by sum of the 2 parallel sides B1 plus B2 into H by 3. If you want this distance, this parallel side first, B2 plus twice of B1 divided by B2 plus B1 into H by 3. I will put this as dot, this as double dot to save the time. Okay. See, from here, B1 plus twice of B2. From there, B2 plus twice of B1. Same thing here. Whatever you wrote here, if you want to learn, once again write here, once again write here. What I wrote here, once again write here. What I wrote here, once again write here. If you want to really learn, have wider space and do it here. What I wrote here, write here dot, that dot. here double dot. If you don't write and be lazy, you are losing. Okay, now second round, one round over. These are when sides are horizontal. Okay. Now second round I will give for when sides are vertical. Okay. This way. Anyone bigger, no problem. One parallel side. I don't know earlier how I taken. One more parallel side. See, this is B1, this is B2, this is H. Or this side offset. I don't know how it was earlier. I don't remember earlier. Okay. This is B1, this is B2, this is H. Or, sorry, here straight. There offset. Okay. This is B1, which bigger, which smaller does not matter. I told you. This is H. Okay, now centroid will be little this side. See, now formula for centroid is from here or from little, not that much actually. Okay, okay. Somewhere here. Okay. This way you don't know. I told this distance furthermore. Okay. Now okay. Either this distance or this distance. G. Here. Centroid may be somewhere here. Either this distance or this distance. Centroid may be somewhere here. Okay. G. This distance or this distance. Why? Along the height. Again formula. This distance is from this parallel side. B1 plus twice of B2 divided by B1 plus B2 into H by 3. From here if you want, B2 plus twice of B1 by B2 plus B1 into H by 3. I will put this as single dot. I will put this as double dot. Now copy here. Single dot copy here. Double dot copy here. This is G. Single dot copy here. If you really want to learn, double dot copy there. Write once again. Okay. This also over. Now there's a unique case is there. A ultra special case. I will tell you now. Okay, right. This much over. Or 1 minute. I will first give examples for you. Once I finish examples, then I will give unique case. Last I will tell you. Okay, now see example 1. Fast right. Very high speed. Second example. Any side, no problem. Don't buy out sides. Third example. Okay. This side, 600. This is 300. All dimensions in millimeter, I told already. Height. 200. This side 120. This side 200. Height. The second question, separate here. Height. 100, 110. This side 180. This side 250. Height. Anywhere I can mark height. 140. Okay. First, tell me. First, area. Sum of the parallel sides divided by 2 into distance between them is 200. Okay, over. Area. Sum of the two parallel sides. 120 plus 200 divided by 2 into distance between them. 110. Area. Sum of the two parallel sides. 250. Anyone first? See, there is no restriction. Which one first? Any side first. 180 plus 250 or 250 plus 180 divided by 2 into 140. Don't tell, sir, last time you took B1 here, now you took B. Don't tell B1, B2, no. Okay, now, centroid is somewhere here. More this side. Centroid is more this side. Centroid is more this side. Okay, that all will come later. Now see. G, G, G. If you want this distance, from here you are doing 600 plus twice of 300 divided by 600 plus 300 into distance between them 200 divided by 3. If you want from here 300 plus twice of 600 divided by 300 plus 600 into distance between them 200 divided by 3. So much explained. Now if it is not clear, I can't do anything. From here 200 plus twice of 120 divided by 200 plus 120 into 110 divided by 3. If you want from here 120 plus twice of 200 divided by 120 plus 200. See my patience into height is 110 divided by 3. Here, if you want this distance, from here 250 plus twice of 180 divided by 250 plus 180 into between them 140 divided by 3. But if you want this distance, 180 from there plus twice of 250 divided by 180 plus 250 into 140 by 3. These are the for 3 cases. Anyway, I thought other one is not required. In the class, usually student will tell, sir, okay sir, sufficient. Now we can prepare ourselves only. But I will tell here, no. When I tell complete, it is always complete. I never believe in half of information. Someone will tell you, do it if you want. Example number 4. 4. This problem. Okay. Example 4. Some number 165 and 110, between them distance 90. Example number 5. $140, 200, between them distance 95. 95, okay. Last example. Example 6. I have to change the pen. This is something. 210, 185, between them distance, say 136. Why means I want 136. Okay. My choice in my class. Start fast. Remember now these are the 2 parallel sides. Centroid here. This distance formula is there. This distance formula is there. Here. Centroid may be here. This distance formula is there. This distance formula is there. Centroid may be here, little upper side. Okay. This distance formula is there. This distance formula is there. Now, before that one, usual tradition, area. 165 plus 110 by 2 into 90. Waste of time explaining. If I explain, class will tell, sir, no sir. There is a limit for explaining. Divided by 2 into 95. Area here. 210 plus 185 divided by 2 into 210. Into 135. 136. Okay. The ink is fading. I will somehow manage now. Okay. Now, centroid, see here. This way. If you want this distance, see, start from here. 165 from here plus twice of 110 divided by 165 plus 110 into 90 by 3. If I explain further, some people will start protesting. From here, 110 plus twice of 165 divided by 110 plus 165 into distance between them 90 by 3. This distance from here 140 plus twice of 200 divided by 140 plus 200. You show me a place where this much explanation is given. If possible, show me. Let me see who is giving from here. 200 plus twice of 140 divided by 200 plus 140 into 95 by 3. See, still people comment, he does not know how to explain. 210 plus twice of 185 divided by 210 plus 185 into 136 divided by 3. From here, 185 plus twice of 210 divided by 185 plus 210 into 136 by 3. 136 by 3. Remember, this way, this way, this way, no standard formula. Okay, over. Now, consider a special case, ultra special case. Rarely you get it. No. By chance, no. Right here. Now, a rare case of trapezium where there is axis of symmetry. There is one, see, rare case. There is one axis of symmetry. Now see, that is possible only for this case. See, either this case or little bigger. You can't get it for this case all. It is not possible. That is one base here, which bigger, which smaller does not matter. This way and this way, or here this way. See, I will call this as B1, this is B2. This I will call B1, this is B2. But see, this distance and this distance, they are equal. Equal here. This distance and this projection, they are equal. Equal, equal. Right here, they are equal. Now one place you write, they are equal. These are equal or same. Equal or same. Okay. Equal or same. Equal or same. Then, see, this is height h. Here, this is height h. Height h. Now, this way centroid is like, see, it little this side. Centroid G. This distance and this one by standard formula. See here. B1 plus 2B2 divided by B1 plus B2 into h by 3. Here. B2 plus 2B1 divided by B2 plus B1 into h by 3. Here. If centroid is here. This distance, see. I will do an axis here, no? See. Anyway, again, right here. This distance is from here. B1 plus 2B2 divided by B1 plus B2 into h by 3. From there, if you want, B2 plus 2B1 divided by B2 plus B1 into h by 3. But this is axis of symmetry. See here. This is axis of symmetry. Here, this is axis of symmetry. Therefore, the centroid will lie here. Therefore, if you want this distance, midpoint, B2 by 2, B2 by 2. If you want here, it is exact center, B1 by 2, B1 by 2. If you want distance here, see, here distance, these two distances. If this is B2, because by midpoint, symmetry is there, B2 by 2, B2 by 2, whereas, I will remove here now. If you want these distances, B1 by 2 and B1 by 2, there is a special case. If axis of symmetry is there, see, this way midpoint, here this way midpoint. For this one, numerical is not required. Still I will give numerical. Why? Because some will tell everything numerical given, but one case he has not given numerical. Okay, fast finish. Now I'll do one thing now. Little homework I'll give for you now. I'll tell you why. Two numerical examples. Two examples. First example. Hundred. This is 100. Okay. This is 100. This full is, I'll put somewhere here. Okay, here. This full is 250 and this is given in the question as 100, 250 100 is 150. 75. Now see here, 75. Here, one more sketch. This full given is 180. Height I have to give. I have to give height here. Height is 120. Here, height I will give here. Height 60. Base, not 180, little bigger, 130. And in the question, this is given. This is 130. This is 90. 130 minus 90 is 40. This is 20 given in the question. Okay. Now do one thing. Area. Directly. 250 plus 100 divided by 2 into 120. I will not explain. Area. Sum of the parallel sides. 130 plus 90 divided by 2 into 60. Little fast I am doing. Now, write one more sketch. This is 250. This is 75. So what is this offset? From 250 subtract 75, subtract 100. Oh, this also is 75. Therefore, these two are equal. Here see. From 130 subtract 20, this distance. 130 subtract 20, subtract 90. Oh, this also comes 20. So this is a perfect case of, this is axis of symmetry. This is axis of symmetry. If I want distance here, both will be 125, 125. Y means, or no, I will write correctly, not 125. Directly 250 by 2 and 250 by 2. Suppose you want here, it is both are 100 by 2, 100 by 2. Whereas here, this is, now centroid will lie somewhere here. Here G, but this distance you have to calculate, this you have to calculate by formula. Here see, this is axis of symmetry. Axis of symmetry. Therefore, if you want these two distances, 90 means 90 by 2, 90 by 2. If you want the distances here, it is 130 by 2 and space is not there. Okay, right there. This 130 by 2. 130 by 2, but centroid here G, this distance you have to calculate. I will give the answer for you. You try it. At least one question, try. What is there? 250 plus twice of 100 divided by 250 plus 100 into 120 divided by 3 will come 51 point. See, this distance will come. I will give answer for you. 51.4286. If I do from that side, actually I can subtract, but I will do it. 100 plus twice of 250 divided by 100 plus 250 into 120 divided by 3 is 68.5714. If I add those two, 68.5714 plus 51.4286, it has to give 120. Yes, 120. Here, this distance this way is, how much this distance total? 130. Okay. 130 plus twice of 90 divided by 130 plus 90 into 60 by 3. 28.1818. 1818. This distance from that side, if you do, it has to come minus 60. 31.8182. Anyway, I'll check the answer. 90 plus twice of 130 divided by 90 plus 130 into 60 by 3. Yes, correct. Okay, done. This will complete the trapezium. Little more example will come in the next class where I will explain trapezoidal loading for you once again. Now last part, circle, semicircle and quadrant. Now start circle, very simple. Not circle, a circular lamina, already I told it, or cross section of a structural member which is circular. Okay. Let D be the diameter. See now, correctly, very important. Let D be diameter. That is, you can make out one thing. I am giving more importance to D. Once you finish all these cases, when you continue the centroid and moment of inertia, and later in structural engineering, we never use R. Radius we never use. Derivation you use, no doubt, but for when you do derivation for later moment of inertia, radius we will use. But while solving problems we always use diameter in structural engineering. See, you tell 10 mm bar. Somebody will ask, 10 mm what? Diameter or radius? People know it is diameter. See, therefore, for circle, every time in structural engineering, most popular is diameter. So I wrote D bigger, R smaller. D equal to 2R or R equal to D by 2. I don't have to explain. See, diameter D, R. Diameter D, R. Center of circle, axis of symmetry, centroid coincides with center. Numerical example here. Okay. Consider diameter 150. So if diameter is 150, radius 75, center and G coincides. Area here, pi d square by 4. See, make a note. I will not explain once again. Circle in terms of diameter, pi d square by 4. Little later, semicircle, it is half, pi d square by 8. Little further, quadrant, pi d square by 16. Radius term, circle, pi r square, semicircle, pi r square by 2, quadrant, pi r square by 4. I will not explain once again. Okay, now, area I done pi into 150 square, mm square, or if you want radius, small I am writing, pi into 75 square, over. Nothing there furthermore for circle. So simple. Okay, now, most important part, semicircle and quadrant of a circle. Both I will systematically explain now. See, first, semicircle. I will do one thing now. To save time, I will first write the sketches here. See, semicircle. Actually not semicircle, semicircular lamina. For those who are commenting. Okay, semicircle. See, let D be diameter. I am giving more important to diameter. And side by side write, let small r be radius. See, D is more important. Little space required, D should come up there. R be radius. That is our more important is this one. See here, semicircle can be either like this. See, it can be like this. Or, I do one thing, I will come somewhere here, the center. Make a note, space problem is there. Semicircle can be either like this, or it can be like this, sometime in the question. Or it can be even like this. Okay, don't worry about shape too much. Those who are commenting, let them comment. It can be like this. Okay. everywhere diameter you can see. Where is the diameter? See, I will put here. This is, I want further more space. Further more space I want. Okay. See. Okay. Here, further that side. So that I can cover everything systematically. Any shape possible. Okay. Okay. Diameter is D. So therefore, see, this is diameter. You can see. And this is C, center. This is C, center. C, center, C, center, C. Now do one thing. Right. Let C be center. If I only put right center, people who comment, semicircle, there is no center. See, it is some edge. Actually, this is not center, means midpoint center. Let C be the center. Center, what? Of circle for which given lamina, our given lamina is a semicircle. Semicircle. That is, you write here, any one example. See, if you write, this is the semicircle, if this is center, then see, you continue for a circle, then this is center. That much common sense required. Center, 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 center. D. See, here. Common for both I am writing, this is D. Common for both. Here, this is D. D, diameter. If that is diameter, this will be radius. Inside I will write. Actually, D I should write dark. Why? D is the most important. 1 minute. Our everything is with respect to D. Little down. Okay. Come down. I will tell it to come down. Okay. Common for both, center I will write. This is the diameter. See, D. Important. This is D. That is, I am giving more important to diameter. Okay, then light line I write. This is radius. This is radius. Here, this is radius. This is radius. Radius, radius. Here, this is radius. This is radius. Here, this is center is here. Center C. This is a diameter common. This is radius. Little side. This is radius. Little small letters. This is radius. Okay. Where is centroid? See, one thing. If this is diameter, this will be diameter by 2. See, actually dark 1 minute. Again dark. Diameter I am giving more important. If this is a diameter, this will be diameter by 2. Here, this will be, see, diameter by 2. This will be diameter by 2. This will be, suppose something wrong in the sketch, not projected properly, don't make an issue of it. Those who want to make the issue, let them make. You don't make issue. Those who are seriously following my class, those who want knowledge from me, you don't comment on those things. Okay, so this over. See, for all the cases, okay, this D has become too dark. Okay, it's laughing. 1 minute. Which is become too dark because ink flow. Okay, no problem. This is diameter by 2. Diameter by 2 or radius. Diameter by 2 or radius. Diameter by 2 or radius. Right, or radius, right, or. Otherwise they will tell, oh, D by 2 is telling D by 2 into R. People are there. See, they will tell, if I put this way, if bracket is not there, D by 2, they will tell into R. See, people are, special people are there, R. Or R. Diameter by 2 or R. Diameter by 2 R. This is diameter by 2 or R. diameter by r, diameter by r, diameter by r. Now, where is centroid? See, there is one axis of symmetry. You should write, see, this is axis of symmetry, right here, axis of symmetry. Here, this is axis of symmetry. I will check the camera once. Axis of symmetry. Here, this is axis of symmetry. Here, this is axis of symmetry. Therefore, centroid lies in axis of symmetry, I told. Just checking the camera for board. Nothing should go out of the board. After putting so much effort, I'll feel frustrated. Okay, now, little common sense. Centroid will lie here. Now, this way midpoint, see, this way midpoint, see, r equal to d by 2, where I wrote, okay, r, I'll put here, r equal to d by 2 once again. D by 2, r equal to d by 2, really, to make it more clear, r equal to d by 2. Because I want everything in terms of diameter, d by 2, r equal to d by 2, r equal to d by 2, little small letter, r equal to d by 2, r equal to d by 2 over, okay. Anything missing means you write it, if it is missing. Centroid, see this way, it is actually here, see, centroid will be either r from here or d by 2. But this way, it is closer this side. Why? See, if you do this way, more area this side. So, this distance, see, this distance is 2d by 3 pi in terms of diameter. This centroid is here, G. It is more closer to this one. So, this is centroid G. This distance is 2d by 3 pi. Here. This distance, see, this distance is 2d by 3 pi. Here, centroid is near here, centroid G. This distance is 2d by 3 pi. Right. Instead of 2d by 3 pi, if you want, you can write r, see, r, 4r by 3 pi. In terms of radius, we are not interested. Right here, r, 4r by 3 pi. Here, r, 4r by 3 pi. Here, r, 4r by 3 pi. Now, somebody is bound to ask, sir, how you know that 2d by 3 pi is nearer to here? How you know that 2d by 3 pi is near to this point? See, this is d by 2. You make a note. This full is, make a note if you want. This full is d by 2 means 0.5d. Correct? Yes. Now 2d by 3 pi will be, see, it is 0.5. If it is closer to this base, this distance should be less than 0.25. See, midpoint is, if it is 0.5, midpoint is 0.25. It has to come little less than 0.25. See, 2 into 1, d is d only, divided by 3, divided by pi, equal to 0.2122. Oh, that will tell you that this distance is 0.2122d. Oh, 0.2122 means this is bigger, 0.5 is there. Half of 0.5 is half of 0.5 is 0.25, less than half. That's why it is nearer here. Write all this correctly and systematically. Make a note. Now, if you want this distance, I won't write, it is d by 2 minus this distance. You know, that much you can make out. Standard formula is from here, 2d by 3 pi. From there, if you want, you will calculate. So, see, 2d by 3 pi, 2d by 3 pi, 2d by 3 pi, 2d by 3 pi, or in terms of radius, 4r by 3 pi, which is near to the base. And other way, this way, midpoint, this way, midpoint, this way, midpoint, this way, midpoint. Why? Symmetry is there. I forgot to write G here. Comment will come. One place G has not done. Okay, this is semicircle. Now I will give you numeric area written. Also forgotten. Say area. Okay, forgotten. For all cases, area equal to pi into d square by 8. Or if you want pi r square by 2, we do not want it. Now we will change over to only what? Diameter. I am not solving for radius, I will not solve in future. But make a note. Okay, now immediately numericals. Full clear numericals. We are coming to end of this class now. Everything is written. When I write by chance, if something is this side, that side, all, do not make the issue of that one. See my effort and how much I explain, even though some may tell he does not know how to explain. That it will not go so fast. It is not hurting me or what? Demoralizing me. It makes me to make laugh. How foolish people can be. How immature they are. Okay. Numerical example. Right here. Numerical example. A semicircle of diameter 150 mm given in the question. Right here. Therefore, this is a question. Right here. Therefore, radius, this is your D. Therefore, radius is diameter by 2 if you want, equal to 150 by 2 equal to 75 millimeter. Therefore, area equal to pi into diameter square 150 square divided by 8. See, now it is the numerical value, directly write. Or you can tell pi into radius square 75 square divided by 2 for your information. Okay, now start. Correctly sketches. 150, no? 150, yes. Sometimes I forget it. Now what I will do, I have to immediately close the recording, open the camera, then go to that level and search what I told. It happens sometimes. Suddenly forgot the number. That's why what I do, I will make a note somewhere. See, 4 cases are possible. See here. It's the upper side. Okay, wait. It is wet actually. It has become little dry now. We are coming to end of the class. Okay, I want to finish in a stretch only. Next round is semicircle. Okay, or a quadrant circle. This way, see now, I am solving only in terms of diameter. I am not using radius. So here, it can be that way, or it can be like this, or, sorry, 4 sketches are there. 4 possibilities are there. See, it can be like this. It can be sufficient. Okay, sufficient most probably. Okay, it can be like this, out of scale, or it can be like this. Okay, manage, or it can be like this. Every possibility I am taking. Everywhere. See, I should go further that side. Okay, wait. Further this side. Space. Actually, space is there. I can utilize the space. 1 minute. I can utilize the space much better way. Why? This must struggle. Space is there. Okay, 1 minute here. It can be like this, or it can be like this, or it can be, I am putting common sketch now to save the time, like this, or it can be like this, so that no confusion for anybody. Here, this is diameter. See, you write here simply dia equal to 150. That's all. Everywhere write dia equal to 150. That's all. Don't write symbol. Dia equal to 150. Diameter you cannot see. This is dia equal to 150 millimeter. Let C be the center. See, center. So this distance is 150 diameter. So if you want this center here, this will be half of 150. You write here 150 by 2, 150 by 2. That is a radius. I don't want radius here. I write common for both. See here. This is 150 diameter and this is center. See. So if you want this distance, it is 150 by 2. This also 150 by 2, 75. Okay, here also. This is center. Diameter is 150. Same projection here. This will be numerical. You write 75. You write later. When you do a problem, you put 150 by 2 only. Because why? Only diameter. This is diameter. 150. Center is here. Circle. Center means not center for the semicircle. Center for a circle for which this lamina is semicircle. 150 by 2 over. Now, see. For all cases, area equal to pi into 150 square divided by 8 over. Radius I am not writing. Radius, get out. I will tell the radius, get out. Okay. Now, see. Axis of symmetry. Axis of symmetry. Axis of symmetry. Axis of symmetry. So, centroid lies here, little this side. This is G. Centroid near the base. G. Near the base. G. Near the base. G. This distance is, see, this distance is 2 times diameter. Diameter, I should not write actually 2 times diameter by 3 pi. I will not write next time. 2 into diameter 150 divided by 3 pi. Radius I won't write. Here, this distance is 2 times diameter 150 divided by 3 pi. This distance is 2 times diameter divided by 3 pi. Radius we won't write. This is 2 times diameter divided by 3 pi over. And this is see, that centroidal axis. See? Later for moment of inertia you require it. Okay, now see here. This way center. This way center. This way center. This way center 150 by 2. So semicircle over. Now the closing part, that is quadrant of a circle. Okay. I write stretch only. I can remove it now. So later no one can tell this is not told, that is not told, nothing like that. Okay. Next, lastly, quadrant of a circle. Quadrant of a circle or a lamina in the form of circle. Let D be diameter. D be diameter. Of course, diameter you cannot see. R be radius. Radius. And then C be center of the circle for which the quadrant, the given lamina is a quadrant. For those who are commenting. Okay. Over. So therefore, tell me right now area. It is pi d square by 16. Circle pi d square by 4. Semicircle pi d square by 8. Quadrant pi 16. Or small letters pi r square by 4. Why? Circle pi r square. Semi pi r square by 2. Quadrant pi r square by 4. Okay. Area over. Now this I will remove now. I will put cases. 4 cases possible. See here. Quadrant can be this way. See here. It can be like this. Quadrant. You write diameter is D. No radius. And if you write here, radius R. Okay, early. Radius R. So, or it can be like this. See here, it can be like this. Diameter D sufficient, radius R, or it can be like this. See, I am giving all the cases so that later nobody should tell this is not done, that is not considered, everything considered. It can be like this, depending upon the question later. Right here, diameter D or radius R. Diameter D or radius R. Not into diameter D or radius R. Now, this is center. Center means it is not center of the, not center for the quadrant, center of the circle. If you complete this way, this quadrant, this given lamina is a quadrant. So, area, I already told you. Now, there is no axis of symmetry here. So, right here, see, this is R. This is D by 2 or radius R. This is common for both. D by 2 or radius R. This is somewhere common for both. D by 2 or radius R. Anywhere else required? D by 2 or D by 2 or D by 2 or here. This is D by 2 or radius R. Okay, now center is here. Center C, center C, center C. There is no symmetry. Now, centroid, if you see from here, near to base, it is near to, see, if you see vertically here, more area in the bottom, centroid will be nearby. If you see this way, right side more area. So, centroid will be near to these two. See, here. This is smaller, bigger, smaller, little down. Okay. Smaller, bigger, here. Centroid will be here. Smaller, bigger, smaller, bigger, smaller, bigger. Centroid will be here, G. Smaller, nearby, far off, nearby, far off. Same point here. Nearby, far off, nearby, far off. This distance is 2D by 3 pi. This also is 2D by 3 pi. If you want one place you write, or only one question, 4R by 3 pi. You write here, or 4R by 3 pi. Next time R you write here, see. This is 2D by 3 pi. This also is 2D by 3 pi. Or you write 4R by 3 pi. Centroid G. Here, this is 2D by 3 pi. This also is 2D by 3 pi. Or you write or 4R by 3 pi. This is 2D by 3 pi. This also 2D by 3 pi. This time or you write or 4R by 3 pi. Okay. That's all. This is for centroid for semicircle, sorry, quadrant of a circle. Okay, now last part of the today's class. Anything pending? One more thing here. See, later one axis like this, one axis like this. That is, they are called centroidal axes. When you do moment of inertia, see, these R will come when you do moment of inertia. Okay, this much sufficient. Okay, lastly, numerical example. Oh, I am also feeling relieved now. Finally, such a long class. I think this is the longest or biggest class I ever uploaded in YouTube. Lastly, numerical example. Quadrant of a circle of, see, diameter I am giving, diameter equal to 200 millimeter, not 200, say 160 millimeter, okay, over, right, or, right, that means radius equal to 160 by 2 equal to 80 if you want to write. Area equal to pi by 4 of diameter square of pi by 4 ಅಲ್ಲ 5 by 16 of 160 square. Pi by 4 is for circle, pi by 8 for semi, pi by 16 in terms of diameter, or pi into radius square, not required, 8 square by 4. Okay, this also over. Now the closing part is final sketches showing the centroid. Okay, that is the last part of this class. How much? 160, 160, 160, 160. I will forget later. 160, 160. Okay. See how it can be. It can be like this. It can be like this, right? Dia equal to 160, or it can be like this, right? Dia equal to 160, or it can be like this. See here, space problem, huh? Okay, okay, space is not there. Further this side, okay, or it can be like this, right? Dia equal to 160. Actually, write a diameter, but usually dia is the short form. People accept it. No one will complain. Only dia is there. Yes, sometimes pet name. Dia equal to 160. Okay, that is D. One place, right? That is our D. For information right here, this is diameter by 2. Once diameter by 2 equal to 160 by 2 equal to 80. For common both, this also is diameter by 2 equal to 160 by 2 equal to 80 if you want. This is diameter by 2 equal to 160 by 2 equal to 80. Where else I have write? It's a common I have write. Somewhere here I'll write here. So that common for both. Diameter by 2 equal to 160 by 2 equal to 80, or it can be R. Or this is radius R. Just make a note if you want. Or this is radius R. Just information. Just only for information. Diameter by 2 equal to 160 by 2 equal to 80, or this is R. R we will not use. We will not use R. Okay, start. Now, for all the cases, somewhere here I write space problem. Yep, it's so tight. Friction is so strong. Abba, coming. For all the 4 cases, all 4 cases right here, area equal to pi into 160 square divided by 16, or interdiameter, or if you want radius, pi into 80 square by 4 if you want right. Now centroid, see here, centroid G, so that this is the axis, later will become centroidal axis. See, near here, near here. By looking only you can make out centroid will be near to this point, centroid G. See, if some sketches are, one is bigger, one is smaller, don't make issue of that one. You, when you copy everything, make a neat copy. In the notes, I will take proper care. I will use scale also in the notes sometimes. G. Okay, now start. This distance we want. See, this distance we want. 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 This we want. This we want. This we want. Start. Formula 2d by 3 pi. 2 into 1 place I will write. See, 2d by 3 pi equal to 2 into diameter is 160 divided by 3 pi. This also 2d by 3 pi equal 2 into 160 divided by 3 pi. Now I won't waste time. 2 into 160 divided by 3 pi. 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 2 into 160 divided by 3 pi, 2 into 160 divided by 3 pi. Oh, forgotten, center. Someone will comment. He told center, not marked it. Does not know how to teach. Okay. I should put an end to that comment. But it is actually not irritating me. I know my capacity. I know people who, my old student, all the students, see, there are more than 200 or 200 to 200, around more than 200 of my students, lecturers in Bangalore alone, which I know them. So that will show that I really know something about structures. Okay, now everything over, anything pending, dia, all over, I think. During all these, if somewhere by chance an entry wrong is there, in the words I told correctly, go through it. I will not, in case I find any corrections required, in the comments I will put corrections. In the description, comment I won't write. Comments I will write, see description for comments. All the corrections I will tell in the description, go through it. But I think description not required. Most probably everything is okay, nothing to worry. Okay, now I am winding up the class. So much effort I have given, so you should utilize it. And this class, because now at the end of the class, only those people who go everything they will hear, you tell others also. Any friend, you share. One more thing I told, you have to share to maximum possible people. See, if I get more views and more watch time, and I feel more comments also required, not such comments. I am not telling you praise me like that. You tell honest comment. See, then I get motivated. Even then, so many are not sharing. They will see and keep quiet. So you send to your friend circle or some other way, groups all, send it. Let the knowledge be spread everywhere. See, this is a free education. I am giving completely free education, complete structure engineering. See, already how much classes? Engineering mechanics, more than not 150, maybe 160 classes are over. Still more 150 more classes. Strength of it, see, engineering mechanics for me is, I am interested, not that way. I give lesser weightage. Strength of materials, I am more happy. Why? That is where concept lies. Structural analysis is my trump card. You see later, when I go to structural analysis, he see how much control I will show you at that time. So many questions which you solve, maybe you may require 1 hour, 1.5 hour, big questions. Some of them I can solve in just 30 or 40 or seconds or 1 minute or 2 minutes. How? Because I know in-depth knowledge. I don't have to worry like people what to do. So many tricks are there. Anyway, that all you worry later. For that one, for competitive examination class, I will think of uploading the classes, but not here. It will be in the members only one. So only those to join the channel. See, I should see some benefit for me also. But this is general knowledge, complete structural knowledge. So use it and also maximum see that it is spread everywhere and share to maximum people. Thank you. We'll meet in the next.